All right, the Algebra 2 final study guide. So this video is a lot longer than I thought it would be, but that just emphasizes the fact that you don't need to watch all of it. You need to just skip around and look at the questions that you want to look at. And pause when you need to in the middle of a question. That's why videos are so great. You can go at your own pace. You can skip through what you don't need to watch. You can pause when you need to pause. Or you can watch the whole thing while you sleep and just learn from osmosis. That works too. So here's the format of this. So we're going to go through all the way up to number 16, and then that's when the CP and the honors study guides come apart a little bit. So then we're going to do the end of the CP study guide and finish the CP study guide, and then we're going to switch over and do the end of the honors study guide. So remember, just skip through everything when you need to, and let's get going. So first off, we're just solving the equation, because that's the basis of everything. So the basis of a lot of this is if you ever have an x squared and an x term, you've got to factor it. So that's what we're going to do. And before we factor it, we got to get it equal to 0, because the whole idea with factoring it is when we get two things that are multiplied together to get 0, if either one of them are 0, then the whole thing is 0. So now we can just set both of these equal to 0 and get our two answers. And it has to be equal to 0 to do that, because what I just said, that if two numbers are multiplied together to be 0, all we need is for one of them to be 0. That doesn't work for any other number. You can't say if two numbers multiply together to get 8, one of them has to be 8. That's like totally bogus. But with 0, that works. So you got to get it equal to 0 first. And that's what we see here. We can't just factor it right away. We got to get it equal to 0 first. So we do that. Now we can factor it. And we get our two answers. So this is -2 double root. So it's still got two answers. It just comes up twice. So it's nice if you let yourself know it's a double root with a little dr there. So now we factor. Can we factor? We can. So I use the Richmond method whenever there's a number right here. So I multiply that number by the back. So it becomes x squared plus x minus 2. And then I factor normally, x plus 2, x minus 1. And then I divide by that original number in front. So that becomes x plus 1 and 2x minus 1. So I get my answers. I go x plus 1 equals 0 and 2x minus 1 equals 0. So 2x equals 1 and x equals 1 half and x equals -1. Cool. So here, there's a few things that I could do. I like the idea of just trying to get the x by itself. Like, we only have an x squared. We don't have an x term as well. So we might be able to get away with not factoring. And it turns out we can, because we can do this, and now we can square root both sides. And what do you always have to remember when you square root both sides? Is a plus or minus 1. So here, we want to factor if we can, but we cannot. So we go, what do? We go quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. So we remember this is our a, this is our b, and this is our c. Just the numbers, not the x's, but including the signs. So that's going to be -2 plus or minus the square root of 4 plus, because -1 times 1 times 4, and then minus, so plus 4 over 2. And we clean it up a little, so -2 plus or minus root 8. You can simplify root 8. So that's -2 plus or minus 2 root 2 over 2. And now we can cancel the 2 because it's in both of them. We couldn't cancel it before, like we can't cancel with that 8 and the 2 on the bottom because the 8's in the square root, whereas the 2 is not, so they're not like terms. But now that we got the 2 outside of the square root, we can. So we cancel all that and we say -1 plus or minus root 2. All right, so f is just like e. We're going to add the 1 to the other side. we're going to divide by 5, and we're going to square root both sides. So when you square root a fraction, you square root the top and bottom. So we can do that if we want to. But I almost forgot the most important part, the plus or minus. All right, we're going to factor if we can. We can. So we're going to factor with the Richard method. So x squared plus x minus 6. You factor as normal, x plus 3, x minus 2, and you divide by 3. You cancel when you can, and you move to the front if you cannot. So it's x equals 2/3, and x equals -1. All right. This one is a nice little break. We just subtract 2 from both sides, divide by 5. A nice other little break, subtract 1 from both sides, divide by 3. Awesome. So we want to factor, but we can't. So quadratic formula. -1 plus or minus the square root of 1 plus 2 times 4 times 4, 32 over 4. So that's -1 plus or minus root 33 over 4. All right, here we can factor. This is the factoring everybody always forgets. We can factor a 2x out of everything. So then we get x minus 2 equals 0. So that's 2x equals 0, x minus 2 equals 0, x equals 2, and x equals 0. All right, moving on. So we have to move everything to the same side. I'm going to think about moving everything to the right. So I'm going to get 3x squared minus x minus 2. I'm going to factor if I can, and I can. So I'm going to use the Richard method. That's x squared minus x minus 6. That's x minus 3, x plus 2. Divide by 3, divide by 3. That's x minus 1 and 3x plus 2. So that is -2/3 and 1. Is that the same as the thing we just did up here? Close, just the signs are switched. Yeah. All right, next. So we factor if we can, but we cannot, unfortunately. So we got to use the quadratic formula again. So it's 1 plus or minus the square root of 1 minus 12 times 4, 48 over 8. So there's not much you can do here, but see how you get the square root of -47. Remember, anytime you get the square root of a negative, that means I has to be involved. So this is 1 plus or minus I root 47 over 8. All right. So now we keep going. We can factor out a 3x here, just like before, and get x squared minus 1 equals 0. And now we can keep factoring. So x squared minus 1. This is the very, very important difference of two squares. It comes up a lot in this study guide. So whenever you have something squared minus something squared, you can always factor that as the something plus the something and the something minus the something. So that comes up like right here, x squared minus 1. That comes up x squared minus 4, or x squared minus 9, or x squared minus anything squared. Or even like something not squared. If it was x squared minus 5, you can go x plus root 5 and x minus root 5. The same way that with these, you go like x plus the square root of 9, which is 3, and x minus the square root of 9, which is 3. So difference of two squares, just absolutely critical. And we use that here. So x squared minus 1, that's going to become, so now we got 3x times x plus 1 times x minus 1. So our answers are 0, 1, and -1. And this is the difference of two squares too, 4x squared. So that's the square root of the first thing. So 2x plus 1, 2x minus 1. So that's x equals 1/2. x equals negative 1/2. All right, we're getting there. Again, we cannot factor, so we have to use the quadratic formula. 1 plus or minus the square root of 1 minus 4 times 5, 20 over 5. So again, we can't really simplify much, but we get the square root of negative 19. So we make that 1 plus or minus I root 19 over 5. Okay, so we'll think about moving everything to the right. So we'll go 2x squared plus x plus 1 equals 0. And shockingly, again, we cannot factor, so we go negative 1 plus or minus root 1 minus 8 over 4. And again, we cannot do much besides make that I root 7 over 4. All right. Here we're going to add the 16 to both sides and square root both sides. X equals plus or minus 5. Here, we're just going to square both sides. Remember, to undo a square root, you got to square both sides. So we get x equals 49. Here we're going to do similar, but we got to get the square root by itself first. So we're going to subtract 3 from both sides. 2 root x equals 4. We're going to divide by 2. And we're going to square both sides. So x equals 4. Here we're going to square both sides, but it gets a little dirtier because the square roots are already by itself. So it's not too bad. We just cancel out that square root. But then when we square the right side, remember x minus 1 squared is not x squared minus 1 squared. It's x minus 1 times x minus 1. So that's x squared minus 2x plus 1. And then from there, we still got work, so we move everything to the right so that we can set it equal to 0. And then luckily, this time we can factor. So x minus 2 squared equals 0, x equals 2. And we got to make sure it works technically. And we see that if we do that, we get root 4 minus 3 equals 2 minus 1. So that's all good. All right, moving on. So just like we cube both sides to undo a cube root, or just like we square both sides to undo a square root, we cube both sides to undo a cube root. So we cube both sides. We get x plus 2 equals 3 cubed, which is 27. X equals 25. So here we got a fifth both sides. So we get 2x minus 3 equals 1 to the fifth. That's pretty easy. We get 1. And then we add 3 and divide by 2. So we get x equals 2. Similar here to the fourth both sides. 3 to the fourth is 81. We subtract 21 and divide by 3. X equals 20. All right, on to the more philosophy question. So this is more like I don't want you to just memorize a phrase of what it is. I want you to know and have an understanding of what this means. And the basics of it is that what does it mean to solve an equation? You say to find an answer, to find a solution, but what is an answer? What is a solution? A solution to an equation is the x value, or the variable value, usually x, the x value, that makes the equation true. That's kind of the basics of it. So like when we solved these equations, we were finding the x values that made the equation true. So like if you look right here, like 25, if you plug in 25, the cube root of 25 plus 2, that equals 3. So that's a true equation. That's like correct. If we plug in a different number, like x equals 1, we get the cube root of 3 equals 3. So that one's correct. If we plug in x equals 1, that's no good. It's like 1 is not a solution. 25 is a solution. So when we're finding the solution to an equation, we're finding the x value that makes the equation true. And let's go ahead and jump down to this one down here. What does it mean to graph an equation? Because it's a similar thing, but it's just when we graph them, we have two variables. So what does it mean to graph an equation? Is to show all the x and y, oops, got ahead of myself. To show all of the x and y pairs that make the equation true. Like when you do a graph, with all of these graphs that we have, where are some graphs that we've done? Wow, not much graphing. Well, here's some, here's some graphs. For all of these graphs that we've done, every point on this graph, so you see the point like right here, this point -3, -3, that means if we plug in -3 for x and -3 for y, we will get a true equation. Like in this case, everything will cancel out and we'll just get 0. So what does it mean to graph an equation? Every single point along here, you plug it in and you get something that works. You get a true equation. That's what it means to graph an equation. It's a visual way to visualize every single point, every single x and y pair that work for an equation. It can just be really useful to see it in a visual way as opposed to just a list, because then you can see if it goes up, you can see if it goes down. It's more easy to see how it changes and how different things affect it. So what does it mean to graph an equation? What does the graph show? It shows all of the x and y pairs that make the equation true. What does it mean to solve an equation? That's when it's just one variable, so it's just the x value that makes the equation true. All right, that's some good stuff. So what do we got now? We're solving more equations. This time we got x cubed. So if you got powers more than x squared, you're going to have to use synthetic division. So that's not bad. We'll just set up with our coefficients. So our coefficients of 1, 2, -4, and -8. We set it up, and we got to find a solution that works. So we know that 1 works if they all add up to be 0. That's not the case here. So 1 does not work. Let's try something like 2. So what we're going to do is we're going to drop the 1, and then we're going to do 1 times 2, and we're going to put that here. And then we're going to add, and then we're going to repeat. So 4 times 2, and put that here. And then we add, and then we multiply, and then, we put that here, and then we add. So there's our remainder. So what do we have now? Our result shows that we have x squared plus 4x plus 4, because this one on the right is always the plane number. This is the x, and this is the x squared, and so on. And so that's one of our factors. Our other factor is we found 2 was a solution. So if 2 was a solution, that means that x minus 2 is the factor. And now we can keep factoring. This is x plus 2 times x plus 2. And this is x minus 2. So what are our solutions? 2 and -2, double root. And we're going to jump through here. We're going to do number 3 and 5 at the same time. So let's down number 5, because see, number 5 is the same. We're just graphing it. So what did we just find? We just found our x-intercepts. Don't even remember them. 2 and -2 double root. I knew they were 2 and -2. I didn't remember which one was the double root. So -2 is the double root. -2, 2. -2 is the double root. And then what's the y-intercept? So remember, y-intercept, you plug in 0 for x. And so that just ends up being this -8 right here. So the y-intercept is -8. And 8's too high to count, so we just put that point there, and we call it -8. And then we just got to connect our dots. So the whole graph is positive, so we know at the end it's going up. And we got to connect our dots. And we know that it's right if it works. Like, for example, if we got the wrong y-intercept and we said it was like up here or something, then we wouldn't even be able to go through it, because we're not allowed to go through the x-axis if there's no x-intercept. Like, we found all of the x-intercepts. We found every place that is allowed to cross the x-axis. So if we didn't say that it was allowed to cross, then it's not allowed to cross. And so if we're not even able to draw the proper graph, we know we messed up somewhere. All right, so let's keep going. Let's do number 3, B. So we got to do synthetic again. So remember the trick. If they all add up to 0, then 1 is a solution. In this case, that happens. So we know that 1 works. So we drop the 1 times 1, add, -5 times 1, add, 6 times 1, add. So 1 worked, so x minus 1 is the factor. And then we have x squared minus 5x plus 6. And we hope that we can factor that. I think we can. So it's x minus 1 times x minus 2 times x minus 3. So, oh, isn't that nice? Our answers are 1, 2, and 3. So let's go down to graph it. We have our x-intercepts of 1, 2, and 3. The whole thing is positive. Our y-intercept, we plug in 0 for x, ends up being -6. Let's put that about here, -6. And it's positive, so we know we start here. And so we're going to cross, we're going to cross, we're going to cross, and then we're down there to hit the y-intercept. So we know we're good. Awesome, awesome. So remember how these roots work. I didn't really say it up here, but if it's a double root, it's going to bounce. And if it's a single root, it just crosses through. If it's an odd root, it crosses through. If it's an even root, it turns around. So double roots bounce, single roots cross straight through. And then let's do C. So C looks all jumbled. So we gotta unjumble it first. We gotta distribute this x, make it x cubed plus 3x. And then we gotta get everything to the same side. So that's gonna be x cubed minus 3x squared plus 3x plus 1 equals 0. And we set up the synthetic division, and we remember our trick. Do they all add up to 0? Ooh, they would if I did that right, because we subtracted the 1 to the other side, so it's negative now. Not there, but in the next step, it's negative. So there we go. So they all add up to 0, because that's negative. So 1 works. So we drop the 1. 1 times 1 is 1, -2. -2 times 1, -2. 1, 1, 0. So what do we got here? 1 is the solution. So x minus 1 is the factor. And then x squared minus 2x plus 1. So we keep factoring. X minus 1 times x minus 1. Another x minus 1. So what do we have here? It's a 1, and it's a triple root. So remember what happens with triple roots when you graph them. It's going to flatten out, and then it's going to continue to cross. So what's the y-intercept here? Just -1 when you plug in 0 for x. You get 0 equals 0 plus 1 plus y. So y equals -1. And it's a triple root. So we know we end up, because it's positive, it's going to come in, it's going to flatten out, and then continue and be looking like that. It's just an x cubed graph. It's just an x cubed graph shifted to the right one. You'll see that in transformations later on in the CP section. So that's pretty good. All right, let's go to the next one. So D, this one's good because there's no constant term. So look what that means. That means you can pull an x out of everything. So then you just have x squared minus 3x minus 10. So you don't even need to use synthetic division. You're just going to go x minus 5, x plus 2. Set all of these equal to 0, so x equals 0, and then x equals 5, and x equals -2. So then let's graph it. So we got 0, 5, -2. The y-intercepts, look how we already have it at 0. You can't have more than one y-intercept. So we know it finishes up because it's positive. We got to hit that. We got to hit that. And we got to hit that. And there we go. So let's see. The next two didn't work, so now we're on G. And this is a long one. We're going to have to do synthetic division twice. Because see how when we do synthetic division once, we're going to get an x cubed? And then we got to do it again. So let's see. We got to remember our trick, because it works a lot. Do they all add up to 0? So let's see. The positive ones get 8, the negative ones get 8. So they all add up to 0. So we know 1 works. So we drop the 1. 1 times 1 is 1. And then we add, and then we multiply, and then we add, and then we multiply, and then we add, and then we multiply, and then we add. Beautiful. So see how if we put this, let's write this out to the side. So 1 was a solution, so x minus 1 was the factor. And what else do we have? So that's our number, that's our x squared, and that's our x cubed. So it's x cubed plus 5x squared plus 8x plus 4. But now we got to keep going because it's an x cubed. So how do you factor an x cubed? You got to use synthetic division. We don't have another answer. It looks like it's got to be negative since they're all positive. So let's try negative 1. So 1, negative 1, 4, negative 4, 4, negative 4, 0. There we go. So what do we have now? We still got the x minus 1. We just found that negative 1 was an answer. So we know that x plus 1 is a factor. And then what else is left? X squared plus 4x plus 4. So we can keep factoring. That's x plus 2 times x plus 2. And then we still have x minus 1 and x plus 1. So our answers are 1, negative 1, and negative 2 double root. So let's come down here to graph it. 1, negative 1, negative 2 double root. 1, negative 1, negative 2 double root. And what's the y-intercept? Negative 4. And that looks good because we know we're going to finish up. We got to hit through there. We got to cross through there. We got to hit there. And we got to bounce. And that makes sense. Another thing to look at, we were saying x to the 4th. So the degree is 4. So when the degree is 4, when the highest exponent is 4, that means that both sides are going up or down. If it's negative, if it's positive, then both sides are going up. Both sides are going the same direction. But see how when these are x cubed, when it's an odd root, they're going opposite directions. So that's always good to know, another way to check your answer. So let's do some conics. We got some conics later on too. But let's do these conics. So these are nice because we don't have to complete the square yet. So first let's do this. How do you tell the difference between the 4 types of conics? So it's kind of a little flowchart. So the first thing is a parabola. So we say we know it's a parabola if only one variable is squared. So if only one variable is squared, it's definitely a parabola. The next thing I would look at is if x squared and y squared have different signs, because that means that it's a hyperbola. It's a hyperbola if x squared and y squared have different signs. So you see down there on B how it's y squared minus x squared. That's different signs. Here, they're the same signs, positive x squared, positive y squared. When that's the case, you know it's an ellipse. When x squared and y squared have the same sign. It doesn't necessarily both have to be positive, because you might, when you schmooty it around, they might end up being positive. They do have to be, like, if you make this if this is a positive 1, then they both have to be positive. But like if that was a negative 1, then they should both be negative. So it's not necessarily important if you're just looking at the equation and trying to determine it. You don't need them to both be positive. You just needed them to have the same sign, either both positive or both negative. When we're ready to graph it, they both have to be positive. And then the little bonus one is just the circle. So it's a circle if the Rx and the Ry are the same. Can I make that better? I don't want to, I've confused people with that. Let's say and. Rx and Ry are the same. Then it's a circle. So let's graph these and do everything we need to do. So this is an ellipse. So we've got our center at +2, +3, because to get our center or our vertex, we look at those numbers, but the opposite signs. And then to get our radii, we look at the square root of the numbers on the bottom. So for the x radius, it's the square root of 4, so it's 2. So we're going to go 2 to the right and 2 to the left. The y radius is the square root of 16, so it's 4. So we're going to go 4 up and 4 down. And that's our ellipse right there. So the last thing we got to do is we got to find the foci. So we got our c value, or sometimes I say our a value. So for the ellipse, you got to subtract the 2 radius squareds. So we say c is the square root of the r major, meaning the longest, squared, minus the r minor, the shortest, squared. So it's the bigger minus the smaller. It's 16 minus 4. And it's the radii squared, so it's just the numbers from the equation itself. We don't have to like square root them. It's not the radius minus the radius, it's the radius squared minus the radius squared. So it's just the numbers from the equation. So we get the square root of 12, which is 2 root 3, which is roughly 3.5. So to graph them, we go from the center, we go up 3.5 and down 3.5. We know it's up and down because it's always along the longest radius. And it has to be along the longest radius because it's got to fit inside of the ellipse. And then the last thing is to write the coordinates. So we think the x coordinate is 2. And then what's the y coordinate? So we went 3, and then we added and subtracted root 12, or 2 root 3. Those are the coordinates of our foci. Okay, so then over here. So this is over nothing, so that means it's over 1. So first off, we got the center. Also, this is x minus nothing, so that's x minus 0 squared. So the coordinates of our center are 0, 2. Our y radius is 1. Our x radius is 3, the square root of 9. But then this is a hyperbola, not an ellipse. So instead of drawing the ellipse, for hyperbolas, you draw a box, you draw the diagonals of the box, and then you decide which way it's opening. So this is y is first, so that means it's opening up and down. So your hyperbola is looking like that and like that. So now we got 2 things. Well, first off, the CP class only has one thing, the coordinates of the foci. So to get the c value here, it's just like for the ellipse, except for the ellipse, you subtract the radius. So I always remember it's the opposite sign. For the ellipse in the equation, it's addition, but for the c equation, it's minus. And the hyperbola is the opposite. It's minus in the main equation. So to get the c value, you add the radius squareds. So it's the square root of 1 plus 9. It's the square root of 10, which is roughly 3.2. So we go from the center, 3.2 up, 3.2 down. And notice how here it doesn't matter which radius is longest. You determine which way the foci go by which way the hyperbola opens. That's all that matters. So the coordinates of the foci then are 0 for the x and 2 plus or minus root 10 for the y. And then for the honors, we got the asymptote equations. So remember how that goes. We use point slope form. M times x minus x1 equals y minus y1. And so what's the slope? Well, the slope is up 1 because we're going up ry, and over 3 in this case because we're going over rx. So we'll write the formula is ry over rx. Also look here how the slope can be positive or negative. So we actually say plus or minus ry over rx. And then what point do both of the asymptotes go through? They both go through the center. So then we use the center for our point. We go x minus h, because that's the x coordinate of the center, y minus k, because that's the y coordinate of the center. So for this one, we just put it all together. We have let's see, ry over rx times x minus 0 equals y minus 2. So we don't even actually need those parentheses there. And that's everything for a hyperbola. Just remember which way it opens. If it's y squared minus x squared, that means it's up and down. If it's x squared minus y squared, that means it's side to side. Now for the parabola, we know this is a parabola because only one variable is squared. And that variable that's squared is y. So if it's y squared, that means that it's opening sideways. If it's x squared, that means it's opening up and down. So again, we got to get the vertex. So just like all the other ones, -2, -3. And then we got to get our c value. So this is our 4c right here. So we're going to go -8 equals 4c. So c is -2. And let's change colors so we can actually see our answer then, since it's going to be opening to the left. So we got our focus. So our focus is 2 to the left, because that's what the c value is, the distance from the vertex to the focus. So we're going to have a focus right there, which means we're going to have a directrix right there. So we'll write those coordinates. The coordinates of the focus is -4, -3. The equation of the directrix is x equals 0. And then we got the lattice rectum. So the lattice rectum is just 4c long. So you're just going to go from the focus up 4 and readjust a little so that we can fit. Down 4. And that's our parabola right there. And we found everything. The parts we got to find for a parabola are the focus and the directrix. The parts we had to find for the hyperbola were the focus, foci, and the asymptote equation. The parts we had to find for the ellipse were the foci. All right, let's do some more synthetic division. So let's set it up. We should always check first and see if 1 works. So 2, 1, -13, 6. Does 1 work? No. Maybe 2? 2, 4, 5, 10, -3, -6, 0. Beautiful. 2x squared plus 5x minus 3. So we'll use the Richmond method to factor. X squared plus 5x minus 6. That's x plus 6, x minus 1. Divide by 2. That's x plus 3. It's 1/2. So 2x minus 1. So what are the answers? 2, -3, and 1/2. We'll go ahead and graph these. So 2, -3, 1/2, y-intercept 6, cross, cross, cross. Next, 6, -25, 23, -6. Does 1 work? No. Let's try 3 maybe. 6, 18, -7, -21, 2, 6, 0. It's pretty good. So we got x minus 3, 6x squared minus 7x plus 2. Remember when you do these, it doesn't matter which one you get first, because like there's 3 answers, right? Like it's x cubed. So there's 3 answers. You can get any one of them first. It's not like you have to like try a specific one first. So let's factor. So again, Richmond method. Divide by 6, so that's 2/3, so that's 3x minus 2. Divide by 6, that's 1/2, so that's 2x minus 1. So you're probably not going to try fractions first. But you could. It would work if you did 1/2. So let's run it. 3, 2/3, 1/2, -6, y-intercept. You're going to go swoop, 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 doop. There we go. All right, we're going to have to do synthetic twice here because it's an x to the fourth. And we got crazy big numbers for whatever reason. Let's try 4. I'm feeling it really just because we're going to get the 16 here. Now let's see. Negative 4, negative 36. 4 times 36, actually another one. Because that's 4 times... Oh wait, why do I know that? Because that's 2 times 3 squared? No, I'm wrong. Anyway, 4 times 3 is 120. 4 times 6, 24. So that's negative 144. 153 minus 144, 9. 4 times 9, 36, 0. Nice. So what should we try next? Maybe like 3? I don't know, that's probably not right. Drop the 4, 4 times 3, 12, 11, 33, negative 3. That's pretty good, it is right. So what is that then? We've got x minus 4, x minus 3, and 4x squared plus 11x minus 3. So then we'll Richmond. X squared plus 11x minus 12. That's x plus 12. X minus 1. And then divide by 4. So we're going to have x minus 4, x minus 3. Divide by 4. So x plus 3. And 4, x minus 1. So we've got 4, 3, negative 3, and 1/4. Nice. Let's put the graph up. So 4, 3, negative 3, 1/4. Y-intercept, negative 36. There, there, and there. And look how they're going the same direction on both sides, since this is a x to the fourth graph. It's an even degree. All right, next one. It's an x to the fifth, but that's not actually bad because we can just factor out an x squared from everything. So we get 3x cubed minus 14x squared plus 20x minus 8. So we're still going to have to synthetic division, but only once. So 3, negative 14, 20, negative 8. Does 1 work? Almost, but no. So let's try 2. 3, 6, negative 8, negative 16, 4, and 8. Nice. So what is that then? That's x minus 2. That's 3x squared minus 8x plus 4, with the x squared on the outside. So then we'll Richmond. X squared minus 8x plus 12, x minus 6, x minus 2, divide by 3. So that we're going to have x squared, x minus 2, and then we're going to divide by 3, so another x minus 2, and 2/3, so 3x minus 2. So what are the answers? 0, double root, 2, double root, and 2/3. Cool, so let's get a little graph. We don't need much, because we just got 2, 0, and 2/3. Positive, we're going to start up. Oh, what are our double roots? That's a double root and that's a double root. So we're going to bounce, we're going to cross, we're going to double root bounce, and back down. And that's an odd degree, so they're going opposite directions. That makes sense. All right. This is ridiculous. So first off, we're going to pull out an x. So I'm not going to write that, but I know we're going to pull out an x. Surely 1 works here. But we still got to do the synthetic for it. So let's see. That's negative 26. So then this is 30. Yeah, 1 works. Cool. So let's run it. 2, 2, negative 14, negative 14, 36, 36, negative 40, negative 40, 16, 16, 0. Nice. So now we're at an x to the fourth. We've got to do it again. Does 1 work again? Let's see. We get 52, 54. Yeah, 1 works again. 2, 2, negative 12, negative 12, 24, 24, negative 16, negative 16, 0. One more time. Does 1 work again? No, it does not. Let's try 2. 2, 4, negative 8, negative 16, 8, 16, 0. I'm too good. I'm too good at picking those. Oh, we still have a 2? Oh, I could have factored a 2 out of everything. That's crazy. So what do we have? We've got x minus 1, another x minus 1, x minus 2, and 2x squared minus 8x plus 8. Now, Richmond method won't really work here. Oh, wait. Also the x that we factored out. So we've got to pull the 2 out, actually. And then we don't even need Richmond method. So we're going to pull the 2 out. And then we'll write this, x minus 1 times x minus 1. So that's x minus 1 squared. And then x minus 2, x squared minus 4x plus 4. And actually, you factor that, x minus 2 times x minus 2. So what we have is 2x, x minus 1 squared, x minus 2 cubed. Nice. So it's 2 triple root and 1 double root. And this is just 2x equals 0, so x equals 0. The 2 doesn't really do anything. The 2 just affects the height. So that affects the y-intercept. But that's about it. So what do we got? We've got 3 answers. 2, 1. Oh, that's a shame. They're all right next to each other. So we're going to go 2 triple root, flatten out and cross. 1 double root, bounce, and then cross. And this is x to the 6th. Yeah, so we expect it to go the same direction. Nice. All right, one more. This is mainly to point out that if you're missing a term, you got to have a placeholder. You can't just not have the 0 there, because otherwise it's like you're doing it with a quadratic, not an x cubed. So you got to have the 0 there to show that you have like 1x cubed, 3x squared, 0 x's, and then negative 4. Because if you just do this, then it looks like this is x squared and this is x. That's not what it is. So you got to have that 0 in there as a placeholder. But luckily 1 works, so we can just wrap through this. So we got x minus 1, and then x squared plus 4x plus 4. Hopefully we can see before we even write that that's x plus 2 squared. So we've got 1 and negative 2 double roots. So let's pop that on. 1, negative 2 double roots, negative 4 with the y-intercept. Boom. And a boom. And there we go. So now let's go back to some conics. And these are just complete the squares. So it's a bit of a grind, but we just got to be careful. So we're going to factor out this 9. Now we'll complete the square. So remember the pattern. We're going to do half of 4 minus 2 squared. And then here we got our big parentheses. So y plus 3 squared minus 9 is minus 3 squared. And then plus 76 equals 0. And then we're going to distribute this 9. So we're still going to keep this for now. And then have 9 y plus 3 squared minus 81 plus 76 equals 0. So now we combine all of the numbers together. So this is negative 5 and negative 4, so that's negative 9. We're going to move that to the other side, and then we're going to divide by it. So we've got x minus 2 squared divided by 9. And then when we divide this by 9, the 9 cancels, and we just have y plus 3 squared, and all of that equals 0. So now we're good to graph it. This is an ellipse because it's x squared plus y squared. So we've got a center at 2, negative 3, x radius of 3, y radius of 1. There's our ellipse. So we got the foci, so we'll say that c is the square root of 9 minus 1, so root 8, which is 2 root 2, approximately 2.9. So we'll graph those, and those will be real tight up against there. And so what are those coordinates? 2, they went side to side with the foci, so the plus or minus is going to go on the x coordinate. And there we go. So let's see, the next one's very similar, but it's a hyperbola. So things are going to go similar, except we're factoring out a negative 9. I'll go ahead and complete the square here. We're going to factor out a negative 9. So y squared plus 6y minus 86 equals 0. And then complete the square. Minus 9. This is our double parentheses here. So that's what I get for not writing it all out. So negative 9, y plus 3 squared plus 81 minus 86 equals 0. X minus 2 squared minus 4. Okay, so now we can combine. We're going to get 9 again, actually. So negative 5, negative 9, yeah, we're going to get 9 again. It's going to be like the exact same thing, except for a hyperbola. So 2 negative 3, it's going to start out the same way. Ah, the 9's canceled here, obviously. So 1, 1, 3, 3. Let's draw our box. Let's draw our asymptotes. And then, let's see, this ended up being x squared minus y squared. So that means it's sideways. And then we got two things. Well, for the CP, we got one thing. We got to find the foci. So we're going to find the C. So this time you add, because for the hyperbola, you add to get the C value. So that's about 3.1. So we can draw them. And that's from the center, which we kind of know because they should end up outside the hyperbola. And then what are the coordinates? Again, they go on the x value. So that's going to be 2 plus or minus root 10, comma, negative 3. And then y'all got to get the asymptote equations for the honors. So you got to go plus or minus ry over rx, x minus 2 equals y minus 3. There's your asymptote equations. So on to F. So we've got a parabola here, because only one variable is squared. So let's complete the square. We're going to have x half of 6, 3 squared, minus 3 squared, plus 8y minus 15 equals 0. So we're going to move all the jump to the right side. That's not the squared thing. So x plus 3 squared equals, don't forget the y, negative 8y plus 24. So negative 8y minus 3. So that's 3 negative 3. That's x squared. So it's opening up, except for it's opening down because it's negative. So that's the vertex. This is the focus. The latus rectum is 8, so 4 on each side. And there's our parabola. We got our directrix to the other way. So our directrix is y equals negative 1. Coordinates here are 3, negative 5. So I was looking at this F problem again, and I realized I made a grave error. Look, I didn't do the opposite sign for the vertex. I don't think I did that anywhere else. But I did everything right besides that. So we're just going to move the whole grid. So we see now the vertex is proper, negative 3, positive 3. So that means our focus is not that. It's actually negative 3, comma 1. And our directrix is not that, it's actually y equals 5. We got another parabola. We're not even completing the square here, actually, because there's no other y term. We just got to move these to the other side and factor out the 4. Y squared equals 4, x plus 2. So, negative 2, 0. This is y squared, it's opening sideways. The 4c is 4, so c is 1. It's opening sideways and positive. So there's our focus. Our lattice rectum is 4. So there's our parabola. We have a directrix 1 the other way. That is x equals negative 3. All right. So I crossed these 3 out because they're a little weird. But I'm going to go ahead and do them because we should be able to do these. We really should. So let's do them. So we're going to complete the square. So we got x squared plus 8x. So that's x plus 4 squared minus 16. And then we're going to factor the 4 out from the y's. So we got y squared minus 4y. So then we got y minus 2 squared. And that would be a negative 4. So then we're going to distribute the 4. So that's negative 16. Plus 31 equals 0. Because see, what happens is we add all of these together and we get negative 1. And we move it over. And we already have 1. Basically what happened was that when I was doing these, I was typing them into the calculator. And I just typed them in kind of wrong. Like I intended for that to be over 4. But this is still legit. What this is multiplying by 4 is the same as dividing by 1/4. So what this really is x plus 4 squared plus y minus 2 squared over 1/4 equals 1. So our y is the square root of 1/4, which is 1/2. And our x is 1. So we can still graph it. Negative 4, 2, there's our center. So this is a ellipse because they're both positive. So our rx is 1 and our ry is 1/2. There we go. Our c is 1 minus 1/4, root 1 minus 1/4, which is root 3/4, which is root 3 over 2, which, I mean, root 3, I mean, it's less than 1, right? Well, it has to be less than 1. I mean, yeah, it's just somewhere in here. Well, less than 1. So somewhere in here. And then we can write the coordinates because they're going sideways. So it's going to be negative 4 plus or minus root 3 over 2, comma 2. That's our foci. All right, this is a hyperbola. We got to factor out the 25. So then we complete the square. I don't know why I'm writing out every step here and I didn't on the last one. And then distribute, and then end up dividing by 25. So x minus 1 squared minus y squared over 25 equals 1. So it's a hyperbola. We got 1, 0. But yeah, this one was fine. This is a little strange because it's so tall and skinny. But you got to make them a little interesting sometimes. So these are our asymptotes. And it's opening sideways because it's x squared minus y squared. I bet these foci are really far out because c is root 25 plus 1, which is root 26, approximately like 5.1. Ooh. Yeah, approximately like 5.1. And that makes sense because it's either way, it's got to be like it would be outside of the box. So 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. Because like they're really far away if it's opening wide. And that's like if it was opening up and down, then it's like 5.1. They would be just outside the box. They're really tight if it's like a skinny hyperbola. But so what? The center was 0, 0? No, the center was 0, it was 1, 0. And they went sideways. So for the foci, it's 1 plus or minus root 26, comma 0. And then the asymptote equations are plus or minus 5, x minus 1 equals y. All right. Let's do the next one. So we got a factor from both here. So let's come down here and squeeze it in here. So we'll rearrange in factors. So 4y squared plus 6y minus 9, so we're factoring the negative, x squared minus 6x minus 109 equals 0. So we complete the square. 4 double parentheses y plus 3 squared minus 9 double parentheses x minus 3 squared minus 9 close parentheses minus 109 equals 0. So we distribute 4y plus 3 squared minus 36 minus 9x minus 3 squared plus 81 minus 109. Am I wrong that that was wrong? So let's make sure we did everything right. No, this is an 8. This was supposed to be an 8. Because 9 times 8 is 72. So then this is a 4, and this is a 16. 9 times 16 is 144. Right? So then negative 36 minus 109. You put the 1, negative 110, and 35. Negative 145 plus 144 is negative 1. Move it to the other side. And right. So that's why this one was weird too. I knew it was weird. That's why I was confused that it was not being weird. Equals 1. But see, it already equals 1. So, just like we did before, we've got to make that y plus 3 squared over 1/4 minus x minus 3 squared over 1/9 equals 1. So ry is 1/2 and rx is 1/3. So that's negative 3, 3. No, I need to put that back. That's a 4. So 4, negative 3. 4, negative 3. And then our y is 1/2. Our x is 1/3. So y is longer. And it's opening up and down. Yeah, there we go. So we can still get our c value. So c is, let's see, 1/4 is bigger than a 9th. 1/4, well, we're adding anyway, so it doesn't matter. So we got a common denominator. So 13 over 36. Root 13 over 36. Which is like a really small number. we're going to end up, I mean, you're just going to end up just outside. It's definitely less than 1. Yeah. There we go. So what's the asymptote equations then? Oh, that's interesting. Because it's 1/2 over 1/3. And then x minus 4 equals y plus 3. But what's 1/2 over 1/3? You keep change flip. So that's just 3/2. Plus or minus 3/2. X minus 4 equals y plus 3. That's pretty good. So there's our asymptote equation. And then the coordinates of the foci, we didn't do that. That's, what's the center? 4, -3. And they're up and down this time, so 4, -3 plus or minus root 13 over 36. Nice. Nice, nice, nice. All right, so again, this is one we don't really have to do, but I'm going to do it for you anyway, because it's still nice to know how to do it. Let's get a better color. Let's go back to our brown. So we're going to factor out this 25 from the x's. So we get x squared minus 2x. And factor out the 9 from the y's. Oh, no. We don't even need to complete the square on the y's, because there's no y term, just the 9y squared. So then we'll complete the square. We'll do it in one step. So x minus 1 squared, it would be minus 1, but we're going to distribute the 25. So minus 25. And so see, the same thing happens. So we end up with 25 x minus 1 squared plus 9 y squared equals 1. So that means we're doing 1 over 25 and 1 over 9. So our Rx is 1/5 and our Ry is 1/3. Luckily, this is just an ellipse. So we're going to go 1/5 and 1/3. It's a little baby ellipse. So, I mean, the foci, we just know they're going to be somewhere there. But let's see. So C is the square root of 1/9 minus 1/25. So that's common denominator. So root 16 over 25, 4/5. Is that right, though? 1/9 minus 1/25. No, because this is not... I did that right there. And I did that right there. Okay. So this is not 25 anymore. This is 9 times 25. So then when we square root, that's going to be that. It's going to be 4/15. Okay. So then what? They're up and down because 1/3 is bigger than 1/5. So our foci are 1, 0 plus or minus 4/15. So that's just 1, plus or minus 4/15. Okay, okay. So now we got to write the equation. I've been told one of these is wrong. So let's see how it's going. So we got our vertex at 2, 1. We got our focus at 4, 1. So that's no problem with that. It's a parabola. And we know it looks like this because that's where the focus is. So it's a sideways parabola, which means it's y squared. So we're going to have y minus 1 squared because we see what our vertex is, 2, 1. So then equals x minus 2, and our c value is 2. So 4c is going to be 8. There we go. The ellipse, this might be the one that's wrong maybe, because we got our vertex at 2, 1, our focus at 4, 1, and 6, 1. Oh, this is messed up. We're going to say this was meant to be a hyperbola. Was it meant to be a hyperbola? No, it was meant to be an ellipse. So what, should we change this to a -4? So that was the one that was messed up. No, it wasn't. No, it wasn't. No, it wasn't. They got me messed up here. That's not messed up. That's not messed up. 2 comma, this is our vertex, this is our focus, this is our focus. That totally makes sense. So this is 1, that's our center. 4 comma 1, we can see that our Rx is the distance from the center to the vertex, so that's 3. Our C value, we can see is 1, so we know 1 is the square root of 9 minus Ry squared. So then Ry squared has to be 8. So we know our equation then. That's x minus 4 squared over 8 plus y minus 1 squared over 9. No, other way around. That was 9 and this was 8. Yeah, nothing wrong with that. Okay, let's do it again. They give us the center here of 2, -3. And then we have a vertex at 2, 0 and a focus at 2, 1. That's legit. So we got the center. We see it's opening up and down, so we can start that. Y plus 3 squared minus x minus 2 squared equals 1. We just got to know the radii. So if this is the center, and this is the vertex, then we know that the Ry is 3, so this is over 9, and we can see that the C is 4. So then we got 4 is root, we add them. 9 plus Rx squared, so 16 is 9 plus Rx squared, so Rx squared is 7. Okay, nothing wrong so far. So this one's a little different because we got a center at 0, 0 and a point at root 2, root 2. Something like that. So I would think about, we can find this radius because that's the distance. That radius is just that distance, which we can do with the Pythagorean theorem. That should just be 2. So the radius is 2. So how we wrote it, it would be like this. But really the better way to write circles, because the radius is just the same, is just multiply both sides by 4 now, and just write x squared plus y squared equals 4. All right, we got 3 more. I'm still looking for a mistake. So here we got a directrix of y equals 0. So that's, waboom, a vertex at 2, 4. That's the vertex? Okay. So C is 4. It's opening up and down. It's somewhat like that. So if it's opening down, it's x squared. We have the vertex, so that's x minus 2 squared equals, C is 4, so 4 times 4 is 16. Y minus 4. Yeah. Okay, so these are fun. This will not be for CP, but we can still do it for honors. So based on the asymptote equations, we know the center is 1, -3, because it's these numbers here but the opposite signs. And we have a vertex at 3, -3. So that tells us it's like that. That tells us it's opening sideways. So we know it's going to be x squared minus y squared. So we can start writing it. We just need the radii. So we see from right here that the Rx is 2. So this is over 4. And then this one, they don't give us the focus, but we remember what this is. This is Ry over Rx. So Ry over Rx is 2. And we just said that Rx was 2. So Ry over 2 equals 2. So ry equals 4. So that's over 16. There we go. All right, let's see. I found no mistakes. We got covertices at plus or minus 2, comma 1. So plus or minus, oh, it's here, plus or minus 2, comma 1. And then another vertex at 0, or the actual vertex at 0, negative 4. So let's move all of this up 1, full 1, 0, negative 4. So our center has to be right here. It's an ellipse, so it's got to be x squared plus y minus 1 squared. And then we just need the radii, and we already have both of the radii. It's x over 4, and y, is that a 5? So over 25 equals 1. All right, so let's get going. So log base 2 of 4. 2 to what power is 4? I mean, that's just 2. We're not going to spend a long time on these if we don't have to. So this one, 3 to what power gets you 27? 3. This kind of looks like the absolute value of n, but this is the ln of 1. And the log of anything is just 0. So log base 10 of 1/10. To get a fraction, you got to use negative exponents. So that's negative 1. 10 to the negative 1 is 1/10. All right, and then here we got to use fractions. As we're saying, 4 to what power gets you 2? Well, you got to take the square root of 4. So that's 1/2. Then ln of the cube root of e. So you got to remember that, how do you write that? As an exponent. Ln of e to the 1/3. So e to what power gets you e to 1/3? So the answer is just 1/3. Log base 1/2 of 8. So 1/2 to what power gets you 8? Well, 2 to the 3rd is 8, but you got to make it 2 first. So it's got to be negative, to flip over the fraction, 3. And then the last one, here you got to do the cube root, is 27 to the 1/3 is the cube root of 27, which is 3. So this is 1/3. All right, and then here, just nice and simple, going back and forth. So I'll go ahead and write down the thing, that log base a of x equals y. We can change that to a to the y equals x. So we're just going to apply that property for all of these. So 4 to the y equals x minus 2. E to the x plus 1 equals 2. And 10 to the 20r equals x. And then here we go in the opposite direction. So first I'll write log base e of 10 equals 2x. But we don't really ever want to write log base e. We'll just write ln of 10 equals 2x. Next, we'll do the same thing. Log base 3 of 2y equals x plus 1. And then the same thing, log base 10 of 50 equals x. And we don't need the log base 10. That's just the log of 50 equals x. All right, that's the most important thing about logarithms, just going back and forth. between the two different types. All right, so then domain. Remember, domain is just that the inside of the logarithm has to be greater than 0. So 3x minus 4 has to be greater than 0. So x has to be greater than 4/3. And then whenever we talk about domain, it's always nice to write it in interval notation. So we'll say the smallest thing x can be is 4/3. The biggest thing is infinity. And remember, we put a parentheses on both of those to show that it's getting closer and closer to that, but never actually gets there. Hang on a second. Okay. And we're just going to do the same for all of these. Nothing too special going on. And same deal, 4x plus 14 is greater than 0. So x is greater than negative 7 halves. So from negative 7 halves to infinity. All right, cool. So now we're going to write these as a single logarithm. So these two are just kind of the opposites of each other. These don't have numbers. All right, write as a single logarithm. So the positive ones have to go on top of the fraction, and the negative ones on the bottom. So we're going to have ln, and of course the bases have to be the same for any of this to work. So we got x on top because it's positive, x squared on the bottom because it's negative, and x plus 1 on top because it's positive. And then we can cancel one of those x's, so it's the ln of x plus 1 over x. We're going to do the same thing here. So we have the log of x squared minus 4 over x plus 2. And so we got to know the difference of two squares. That's going to factor. So that's the log of x plus 2 times x minus 2 over x plus 2. So then those cancel out. And it's the log of x minus 2. Cool. So here they're both negative, which means we're just going to have a 1 on the top. We can't just have nothing on top, because then, like, it would just be 0, and that's no good. So we got to have a 1 on the top, an x on the bottom, and another x on the bottom. So that's the log of 1 over x cubed. So that's a good answer. If we wanted to, we could also make that negative log of x cubed. Or what do we even want to do? I don't know. Maybe we want to bring that 3 out to the front. Negative 3 log of x. That's pretty nice. That's probably like the best answer, to be honest. Yeah, I haven't been live for a while. We have finals coming up, so I'm really just trying to make like an answer key for this and a video to go along with it. All right, expand the log. So now we're going to do the opposite. So the things on the bottom are going to be positive, and we're going to be adding them. And the things on the bottom, we're going to be subtracting them. And then it's nice to do this. This is x to the 1/2. So we can make that 1/2 log of x minus 2, or 1/2 log of x plus log x minus 2 minus log x plus 1. All right, so we're going to factor this one first. X plus 3, x minus 3, and x, 2x plus 1. So that's ln of x plus 3 plus ln of x minus 3 plus ln of x plus ln of 2x plus 1. All right, another long one. So we're going to have the log of x squared, and then we're going to bring the 2 out to the front. So that's 2 log of x plus log of x plus 2 minus log x plus 1 Ooh, then we're going to factor this. This is x plus 1 times x minus 1. So actually we're going to do minus log x minus 1 minus 2 log x plus 1, since there's 2 of those down there. All right, nice. So now more fun. Solve the equation. So 3 to the 0 equals x minus 2. And how did the rest of the refraction project you were working on go? Yeah, I kind of stopped. I got to where it like worked for 2 points. And then I think I was at like a really hard spot. So I decided to quit with that. Let's take a look at that actually for a second. I don't know if you saw it at its last. So yeah, 4 weeks ago was the last time I saved it. But yeah, I got it working. Actually, just for the top part. That's too bad. I thought I had it for the bottom part too. But yeah, I definitely did stop working on that. Oh, and then you can change that like that. I had it with 2 points at one point. I have a few versions of it saved. And then they don't bounce. Yeah, I stopped doing that. This is my recent thing. This was cool. You can choose colors. This is a good one. This one's pretty too. I'll go back to it at one point. Once I have more time. I'll have way more time once the school year is over to do all this sort of stuff. Like, this is for school right now. That's the only reason I'm even doing it. Anyway, so back to number 15. So all of these we're going to solve differently. That's just kind of what's the most fun about them. So this one, we're just going to turn it back into an exponential equation. 3 to the 0 equals x minus 2. So that's 1 equals x minus 2. So x equals 3. And then this one, we're going to combine it into one logarithm first. That's actually what we have to do a lot of the times. Combine it into one logarithm. That way, we can rewrite it as an exponential equation. And then, it's not exactly easy, but we can do some stuff from there. So first off, this is 8, which means we're going to make that 2. So that's going to be 2x minus 4 equals x. So then x equals 4. So we want to get 8 in there? Yeah, that makes sense. And then, yeah, we're going to do the same thing here. So log base 2 of x times x plus 2 equals 3. I've done this before. So that's 2 cubed equals x squared plus 2x. So x squared plus 2x minus 8 equals 0. And then you can factor. So that's x plus 4, x minus 2. So that's negative 4 and 2. But you have to reject that negative actually, because you see how when you plug it back in, that gets that. And that's definitely no good. No, this is Algebra 2. Yeah. So then we go on to here. And we just remember this is log base e. So this is just e to the 5th equals x. I've done that one before too. This one, x squared equals 25. So x equals 5. It can't be negative. We'll do that. We'll do that. It can't be negative. You're not allowed to have a negative 5 down there. That's no good. All right, so here we're going to combine it into one log. So the log of x cubed over x squared equals 1. So it's just the log of x equals 1. So x equals 10. Okay. Yeah. Those were all really easy. All right, so here's some money questions. If you invest $12,000 in an account that gives 5% APR compounded monthly, how much money will you have in 20 years? So we got two main formulas here. A equals P times 1 plus R over N to the NT, and A equals P times E to the RT. So this is the one we're going to use when it compounds, I'll say periodically. And we're going to use this bottom one when it compounds continuously. So this first one is compounded monthly. So it's going to be 12,000 times 1 plus 0.05 over 1 plus 0.05 over, it's compounding monthly, so 12 to the 12 times 20. And then we just type that in the calculator. Where's the other parenthesis? There it is. Raised to the 12 times 20. 32,551 and 68. All right, so another one is continuous. So we still got the 12,000. 0.045 times 20 years again. Yeah. So that's only 29,515. So basically, I guess I'll write that out. 12,000 times e to the 0.045 times 20. So the continuous doesn't really make a difference. What really matters is the interest rate. So let's use this next one. So now we have $1 million or $1.5 million compounded daily 3%, 10 years. So 1 plus 0.03 is 365 days in a year. So we're compounding 365 times per year times 10. And then we just pop that in. 1, 2, 3, 4, 5 times 1 plus 0.03 over 365 raised to the 365 times 10. So it turns into $2,024,763.25. Nice. And then it says, what if we got 4% instead? I bet that's going to be a pretty big difference. So it's going to be exactly the same here, except for a 4. So we'll do that, but put a 4 here. And what does it say? How much more money would you get? So we'll do that. It's 2,237,688.9 0, 0. And then we're going to subtract those. So we want to do that minus that. And that's 212,924.75. Nice. And then we have compounding continuously. So that's the 1.5 million times E, see, we're at the 3% now, times 10 years. So that's 1, 2, 3, 4, 5 times E to the 0.03 times 10. There we're making 2,024,788.21. So what's that difference? Like, so minuscule. Looking for that number right there. $25. So very, very little difference in all of that. Very, very little difference. So now that we're here, the study guides diverge a little bit. So what we're going to do is we're going to go do the honors ones afterwards. But for now, we're going to jump down to the CP section. So for CP, this one is also an honors, but it's number 25 for honors. So you're going to have to skip ahead to the honors section where I talk about that one. But let's talk about your number 18 and 19 here. So first off, we got the parent functions, the parent graphs, and we just got to know those. So that's a straight line, that's a parabola, this is our cubic function, which is our little s. This is like a parabola but flatter at the bottom. It's a very subtle difference. This is our v. This is our little double swoop where they're diagonal from each other. This is our little double swoop that are next to each other. This is our swoosh, and this is our double swoosh. So we got to know these basic graphs, because when we transform them, we're just transforming these basic graphs. So let's go through. So here you see we're multiplying. So if we multiply it, we're going to be making it taller and skinnier. You see how we take that absolute value function and we make it taller and skinnier. We'll go ahead and do parent functions too. And this color is just since it's right next to it. So there's our parent function. We multiply by 2, makes it taller and skinnier. Should we do all of our parent functions first? I feel like that'll be quicker. So we got that. We got x cubed. We got x to the 4th. We got 1 over x. We got the absolute value, square root, 1 over x, 1 over x squared, cube root, x squared, square root, x to the 4th. I don't know why I'm putting arrows on some of them and not others. They all should have arrows. Parabola, and 1 over x. All right, so there's all of our parent functions. Let's switch to brown. Let's do the transformations. So if we add 2, we're just moving the entire graph up 2. Add 2 on the outside, that makes it up and down. Negative, so we're just going to flip the entire thing upside down. It's a negative on the outside. We're flipping the whole thing upside down. This is a negative on the inside, so we're flipping the whole thing sideways. But see how if we flip this whole thing sideways, it actually doesn't do anything. It just lands back in on itself. Then we got absolute value, so plus 1. That's on the inside, so it's moving it sideways and opposite. So it moves it in the negative direction 1. Here we're subtracting 2, so we're moving it in the positive direction 1. Here we're multiplying by 3, so we're making it taller and skinnier. Here we're adding 2 on the inside, so that's going to move it sideways. So let's see how before we had this vertical asymptote right here. Now that we're moving it sideways 2, that vertical asymptote's going to be over here. And that's going to guide our new graph. Negative, it's just going to flip it all upside down. So that bottom one is going to flip up here. That top one is going to flip down here. 2 times x squared, so it's a 2 on the outside. So we're multiplying all the y values by 2. So it's going to pull it out more. That makes sense. Here we're multiplying all the y values by 3. So it's also going to pull it out more. Make it taller. This one's dividing by 2. So that's going to make it shorter. This one's adding 2. So before we had our asymptote right here, now it's going up 2, so our new asymptote is going to be right here. And that's what our graph is going to look like. So make sure that they're both going up. It's not one going up and one going down. A lot of people always try to do that. Here we're dividing by 2, so it's going to make it shorter. Here we're dividing by 2, so it's going to make it shorter. Here we got a negative and a negative. So the first negative is going to flip it down. The second negative is going to flip it over. And that's it. So that's it for the CP study guide. On to the honors study guide. Which of these are functions? So this is a function because y is by itself. If y is by itself, then it's definitely a function. This next one is definitely a circle. Oh, well, it's a circle. That means it's not a function. And you know it's not a function if y is squared. If y is squared, or like y is absolute value, then it's not a function. Because the idea is you're kind of trying to solve for y. So if you try to do that, it's like you do that. And then if you square root both sides, you got a plus or minus. And so now whenever you plug in values for x, you're going to get 2 different answers for y, the positive and the negative answer. And that is no good. So that is not a function. Because what does it even mean to be a function? Each input has one output. And so like this one, this is a function because each of these inputs has only one output. Whereas this one's not a function. You see a lot of these have multiple outputs. So that one is not a function. This one is also not a function because you got y squared. You'd have to solve this like a quadratic and get a plus or minus from the quadratic equation. So that is not a function. This one is a function because it passes the vertical line test, is why. Oh, I skipped these two. That one's a function because it passes the vertical line test. This one is not a function because it does not pass the vertical line test. This one passes the vertical line test. Even here in the middle, this is an asymptote. So it just never crosses that vertical line. This one definitely, I tricked myself. That one is, because each input all goes to 7. This is like the function f of x equals 7. No matter what you input, you always output 7. And this one is not a function because of the absolute value. This one is a function because you can do something like y equals 2x squared plus x over 2x and solve for y, no plus or minus. And same with this actually, because you can go y is the cube root of x plus 3 over 2. So that one is as well, even though it's y cubed, that one is still a function. All right, number 18. Find the inverse of the function. So let's get back to a color. We're doing it in brown, right? Yep. Okay. So 18, find the inverse of the function. So of course this is y equals 2x minus 3. So the first thing we have to do is switch the x and the y, and then we got to solve for y again. That's the gist of all of these. So we got to get y by itself. We got to add 3 to both sides, and we got to divide by 2. So we get y equals x plus 3 over 2. And that is the inverse function. Remember, if you want, you can always write inverses as f of negative 1. So that's like f inverse is x plus 3 over 2. All right, same thing here. We got to switch the x and the y. So x equals 2 to the y. And then we got to solve for y. And that's just straight logarithms. So that's log base 2 of x equals y. And that's what the inverse function is. Just right there. So let's continue. C. So we've got, we'll switch the x and the y. So x equals ln of y minus 3. And then we got to get y by itself. So here we're going to have to use a exponential function. We got to put it back into an exponent. So that's going to be e, because ln is log base e, to the x equals y minus 3. And then we're going to just add 3 to both sides. So y equals e to the x plus 3. There's our inverse function. Okay, next, down here. So this happens a lot where you got the fractions. So a really important technique comes in here. Well, not so much yet. On the next one it will. But anyway, so we switch the x and the y. Now we got to solve for y. So I'm going to cross multiply. So I get xy minus 5x equals 2. Anytime I have a fraction, I'm just always tempted to cross multiply. So then we get that, and then we're going to divide by x. So 5x plus 2 over x is our inverse function. So let's do this one. X equals y plus 1 over 3y. So when you have this, remember what you want to do. You want to get y by itself. So how we're going to do that is we're going to get all of the y's to one side. So we're going to have 3xy minus y equals 1. Because then once we have that, we can factor out the y. So we have y times 3x minus 1 equals 1. Because now look, now since we just have y times that, we can just divide by that. So 1 over 3x minus 1. That's going to be our inverse function. So let's do the exact same thing over here. So we're going to switch them. We got x equals negative 2y plus 1 over y plus 1. So we're going to do the same thing. We're going to cross multiply. So xy plus x equals negative 2y plus 1. We're going to get everything with a y to one side and everything without a y to the other side. So we're going to have xy plus 2y equals 1 minus x. Because once we do that, we can do just like before. We can factor out that y and then divide. So our inverse function is y equals 1 minus x over x plus 2. And that's our inverse function. Cool. So just remember the gist of those is you switch the x and the y. Okay, let's keep going. Solve the equation. So here, this is just to get us started. That should be pretty obvious. X equals 7. Here, we got to try to make the bases the same. I would do, you could always do like 8 squared is 64, and then 2 to the what power gets you 64. But I would do something like 8 is 2 cubed squared, and now you have an exponent raised to an exponent, so you multiply the exponents, and so you can see that x has to equal 6. Here, make the bases the same. This is 3 squared to the x plus 1. So this, then you again multiply the exponents, and then you distribute the 2. So you got that. And so now we got to just compare the exponents. 2x equals 2x plus 2. These cancel out. We get 0 equals 2. That's no solution. Interesting. Yeah, that has to be no solution. All right, the next one. Next one looks like it'll have a solution. So here we can't really make the bases each other very easily. So we're going to have to change both of them, because we can make both of them a 2. This is 2 to the 2x, and this is 2 cubed to the 2x minus 3. So then we can compare, well, let's do it out first. So we'll distribute this, we'll multiply the 3. So we'll get 2 to the 6x minus 9 equals 2 to the 2x. So then we get to compare the exponents and say that 2x equals 6x minus 9. So let's move the 9 over, move the 2x over, and divide by 4. So x equals 9/4. Neat. All right, so here we should combine these together first. So this is like 2 to the 1. So since we're multiplying and they have the same base, we can make that 2 to the x plus 1. Whoops. 2 to the x plus 1 equals 2 to the 2x minus 1. So then we know that x plus 1 has to equal 2x minus 2. So then x equals 3. Cool. We're going to do the same thing here. It's just a bit more involved. So this is 2 to the 2x. So when we add these, we're going to have 2 to the x plus 1 plus 2x equals 2 to the 3 times 2x plus 3. Wow. Okay. So we'll clean that up a little bit and compare the exponents. 3x plus 1 equals 6x plus 9. So we're going to get negative 8 equals 3x. So x is negative 8/3. That's a good answer right there. That's a good answer. All right, so now we get into the more complicated ones. These can be kind of grueling. So here's what we're going to do. We're going to take the log of both sides. But we got a couple ways we can think about it. My preferred way is to take the log of both sides. It's not really better, but that's what I like to do. And we're going to make the base the same as one of the bases. So we're going to log base 2 both sides. The reason we're going to choose log base 2 is because then we have something like this. So then we can move the exponents to the outside. And so what happens over here, we have x plus 1 times log base 2 of 2. And log base 2 of 2 is just 1. So we can really ignore that. We can't get both of them to go away, but we can at least get one of them to go away. So that's a pretty good deal. So then we have x plus 1 equals x log base 2 of 3. And then we got to do stuff kind of like we did with the inverse functions. We got to get all the x's to one side. So we're going to have x minus x log base 2 of 3 equals negative 1. And then I'm going to factor out the x. And then I'm going to divide. So I'm going to get x equals negative 1 over 1 minus log base 2 of 3. And that's not a pretty answer, but that's an answer. If you want to make it a little better, you can like deal with the negatives. So you can cancel out that negative on the top and switch the bottom around. And that's a little prettier. So that is a better answer. And that's a fine answer. We don't need to go any further than that. So let's do the same thing up here. So we're going to log base 4 both sides. Well, no, let's do a different one here. So another way we can do it, and this actually kind of skips a step, is think about our log pattern. That log base a of x equals y is equivalent to a to the y equals x. And then we kind of look at each part. So we could say that that's our a, this is our y, and this whole thing is our x. And we can do that. So we can make this then log base 4 of 6 to the 2x equals x minus 3. And that's a fine way to think about it too. It's pretty similar to the other way. Because now we're going to move that out to the front. So we have 2x log base 4 of 6 equals x minus 3. And we're going to do the same thing we did last time, where we just got to get all of the x's to one side and factor out the x and then divide. So we're going to make this 2x, well, all of that nonsense. 2x log base 4 of 6 equals x minus, no, come on. I got sidetracked trying to check my email. So we get that, and then we're going to factor out an x. 2 log base 4 of 6 minus 1 equals negative 3. And then divide. So x equals negative 3 over 2 log base 4 of 6 minus 1. And that's a decent answer. Again, we can deal with the negative and flip around the bottom. I think that's a good answer. I wonder what more we could do. We could make this answer better though. So this is optional, I suppose, but let's do this. I want to look at the bottom. I want to look at this right here. Let's add a page so we got more room. So let's copy this down and see what happens here. So first off, by the secret property of logarithms, we know that this is 2 squared, so we can bring that out to the front. And this is just log base 2 of 3, or 2 of 6. But if this is log base 2 of 6, that means that's log base 2 of 3 times 2, which means we can change that to log base 2 of 3 plus log base 2 of 2, which is log base 2 of 3 plus 1. And the reason that's so nice is because now what I'm going to have here is 3 over 1 minus log base 2 of 3 plus 1 And now when you distribute the negative, those just cancel. So it's 3 over negative log base 2 of 3. That's interesting. That's pretty neat. Oh, wait. Oh, no, that would be 8 then. Okay. That's pretty neat. Wow, I keep doing that. All right. Anyway, let's continue. Huh. Well, I guess there's interesting things you can do. There's just always interesting things you can do. Like this is 4 times 3. So if we wanted, we could divide both sides by 3. So divide by 3 to the 1. If you have an exponent over an exponent, you can subtract. So that's 3 to the x minus 3 equals 4. And that just makes things nicer. Then we just go log base 3 of 4 equals x minus 3. X equals 3 plus log base 3 of 4. Yeah, so I guess that was just nicer because there wasn't an x in the exponent. There was no exponent on this number. Like, we're just going to do the same thing here. We're going to say that log base 2 of 3 is equal to x squared. And then we're going to square root both sides. And so we get x equals plus or minus the square root of log base 2 of 3. Yeah, that's fine. What is that? I mean, that's just like a number between 1 and 2, right? Log base 2 of 3, and then do square root of the answer. Yeah, okay. All right, continuing on, back to the more tougher ones. So we're going to do log base 5 of 4 to the x equals x plus 2. Just doing the same thing we did here on G using our main log ideas. And then we're going to bring the x to the front and do the same deal where we get all the things with an x to one side. So subtract the x over. Well, here, that way we can factor out the x. So we get that. And then we can divide. So x is 2 over log base 5 of 4 minus 1. All right, lastly, why is that? I didn't even go down to the extra page. I added the whole page. I didn't even go down to the extra page. Let's move that down there. All right. So what's that 5 doing there? That's ridiculous. So what? We'll do the same thing. We'll do log base 3 of 2 to the 3x over 5 equals x. That's fair. So now we have like a division inside of a logarithm. So I would split that up. I would make that log base 3 of 2 to the 3x. Because we can't just bring that 3x to the front yet, because it's not the entire inside of the log raised to the exponent. But once we split it up like this, now it is the entire inside of the log raised to the exponent. So we can bring it out to the front. And then we're going to do the same deal where we get all of the x's to one side and all of the not x's to the other side. So we can factor out the x. And then divide. And it's not so much a pretty answer, but that's okay. Log base 3 of 5 over 3 log base 3 of 2 minus 1. That's the answer. A few other forms you could get it in, but that is my answer. So if you get it in another form, what you ought to do is just like plug it into numworks, see what the decimal is. I'll do this one, I'll write it down. And then put yours into numworks and see if you get the same decimal. So this is roughly 1.64. So if yours looks different, but it's also 1.64, then you're good. All right, let's keep going. So more solve the equation. This time it's in a logarithm, and we got to go the other way. So 2 cubed equals x, so x equals 8. X to the 4th equals 16, so x equals 2. Whoa. Oh, well, remember, log base 2 of 3 is just a number, so we're good with that. We'll just multiply both sides by 2. 2 log base 2 of 3 is x plus 1, and then we'll subtract. So it's not a satisfying answer, but it is an answer. 2 times log base 2 of 3 plus 1. No, minus 1. Basically, you know it's an answer if there's no x in it. Like I'm telling you what x is. X is 2 times log base 2 of 3 minus 1. And that is just a number. It may not seem like it, but that is just a number. So next, this is also just a number. So I would use the secret property of logarithms here, that 8 is 2 cubed. So we can bring that out to the front and say that's x times 1/3 log base 2 of 2. So then that just all goes away. So it's x over 3 equals 5. X equals 15. That was a weird one. So these are kind of the more normal ones that we have. So we're going to combine these into one log. That's generally the idea, because we're adding 2 logarithms. So we can combine them into one logarithm, like this. Because then we can put it back into exponential form. 4 squared equals x times x plus 6. Because now we're going to distribute, and we're going to get everything to one side. That way we can factor it, and we can get our answers. But the last thing is we just have to make sure that when we plug them back in, we got to make sure we're not getting the log of a negative, which is no good because we do here. So negative 8 is not a good answer. 2 is the only answer. And yeah, that checks out. So that's the deal with a lot of these. You've got to combine them into a single log. And then, it's not log base 3 though, it's log base 2. So that then when you put it back into exponential form, 2 to the 4th, 16, equals that. And what is x plus 3 times x minus 3? We ought to know that. That's x squared minus 9 equals 16. So then we subtract the 16 over. And we factor again. Now we can factor. Again, we should know this. This is x plus 5 times x minus 5. So we get 5 and negative 5. And then let's make sure. So if we plug in negative 5, that's definitely no good, because we get a negative inside of a log. But if we plug in 5, it's fine. So there we go. Ooh, look here. Here you're subtracting. So we're still going to combine it into one log again, but this time into division. So we're going to have log base 3 of x squared minus 4 over x minus 2 equals 1. And now, hey, look, it's difference of 2 squares again. This is x plus 1, or x plus 2, times x minus 2. So we can cancel these x minus 2's. It's just log base 3 of x plus 2 equals 1. So now when we put that into exponential form, we get x equals 1. Nice. So that's it with logarithms. Then we come into plotting angles. So here we just got to put them where they are. Whoa, wait, no, there's a lot we have to do here actually. So we got to plot the angle. We got to state the angle's quadrant. Let's make a little chart. So we got the quadrant. We got, I'll say the measure. We've got equivalent, if needed. So the quadrant is quadrant 1. The measure, 60 degrees times pi over 180. So that's pi over 3. 240. So we're going to again multiply by pi over 180. Cancel, cancel. What else cancels? A 6. 4/3. 4 pi over 3. Quadrant, see 240, so that's 60 more than 180. That's there. That's quadrant 3. And there is no equivalent angle. So let's see, 7 pi over 4. That's right here. Because that's quadrant 4. What does that measure? That's pi over 4 less than 2 pi. So that's 45 degrees less than 360. So that's 315. Negative pi over 6. Well, so that's let me put these down. Cool. All right, cool. So negative pi over 6. That measure is negative 30 degrees because pi over 6 is 30 degrees. So that's equivalent. So you got to add 360. So that's equivalent to 330 degrees. And that's going to end up in quadrant 4. Because remember, negative angles go backwards. 7 pi over 3. So that's more than 2 pi. So if we subtract 2 pi, which is 6 pi over 3, we just get pi over 3. So this is equivalent to pi over 3, or 60 degrees. The measure, it's actually all the way around and plus another 60 degrees. So that angle measure is 420 degrees. Or you could also just do, is there room here? 7 pi over 3 times 180 over pi. Cancel the pi's, cancel this, leave a 60. 60 times 7 is 420. And that's going to be in quadrant 1. Oh, this is a big one. So let's first off convert it into radians. Let's just do it like this. Pi over 180. Cancel, cancel. We'll cancel the 6, leave an 11. So it's negative 11 pi over 3. And then what? We got to keep adding 360. So you add a 360 and you get negative 300. You add another 360 and you get 60, which is pi over 3. And that is in quadrant 1. All right, cool, cool, cool. Find the area and the arc length given. So the way we think about these is you first off got to know the area formulas. A is pi r squared. C is 2 pi r. And we know everything. Well, no, that's the area. So that's the area. Let's do the area first. So what we're going to do is we're going to find the area of the full circle. And then we're going to multiply by the fraction that we actually want. So the fraction that we actually want is this 240 degrees out of 360 degrees. And that's going to be times 4 squared, pi, because the area is r squared times pi. And then we just have to simplify everything. So the zeros cancel. Let's see, this 12s cancel. This just becomes 2 thirds. And then 2 times 16 is 32. 32 pi over 3. for the area, 32 pi over 3. And for the circumference, it's going to be the same thing. So we'll use the fact that we got 2/3, that 240 over 360 was just 2/3. And then we'll multiply times 2 pi r. So that's an 8. So this time it's just 8 times 2, 16 pi over 3 is the circumference. Cool. So we'll do the same thing here. Here it's in radians, so we could convert it into degrees if we wanted to, but we don't need to. We just know how many radians are an entire circle. That is 2 pi. And then we'll do the same thing from there. Oh, I didn't write down what the radius is. It's 2 units though. It's 2. Just like this is 4 because it's 4 units, this is 2 because it's 2 units. So the r is 2. So that fraction times pi times r squared. 4 to get the area. And then we'll simplify. So we're dividing fractions, so we'll keep change flip. 3 pi over 4 times 2 pi times 4 pi. So the pi's cancel. These 4's end up canceling. It's just 3 pi over 2. That's a gnarly 2. I'm leaving it though. And then we got the circumference. Or the arc length, better to say. So we'll do the same thing. We'll take this 3 pi over 4 over 2 pi times 2 times pi times 2. So actually look how it's the exact same thing, because this is just 4 pi over here. It's the exact same thing, since 2 times 2 is the same as, well, 2 squared. Yeah, you just get the exact same thing. That's cool. All right, so here we're going the other way, and we're trying to find the angle, and they give us the area. So we know the area, and remember how we got that. So we took that angle out of the whole circle. We'll do degrees, so 360 degrees, and then multiplied by pi r squared. They tell us that the r is 4, so times 16. And then we solve for theta. So it's going to have a pi in it. That's kind of gross, but that's okay. So we'll divide both sides by 8, cancel that out, and leave a 2. And then, we're going to multiply by 360, and then we're going to divide by 2 pi. And that's the answer. It's 180 over 2 pi. Yeah. That's the angle. 180, not over 2 pi, over pi. 180 over pi, which is like 60 degrees-ish. So now when we find the arc length, oh, that's kind of annoying. So for the arc length, let's do it perfect. So we'll do 180 over pi over the whole circle, 360, times 2 pi times the radius. Okay, so we'll keep change flip, 180 over pi times 1 over 360 times 2 pi 4. See, that cancels and leaves a 2. That cancels that. That cancels that. So it's 4. Huh. That was a fun problem. Let's do it again. Should we maybe do it in radians instead? Let's try that. So let's do it in radians. So let's set this up. Let's put degrees. So let's do it in radians this time. So now we know the arc length. So we know that theta out of the full 2 pi times 2 times pi times r, while r is 3, gets us the arc length of 2. So then we can solve for theta. Theta is 2/3 radians. So radians don't have to have a pi in them. They just normally do. Just like arc lengths normally have pi's in them. So now we can find the area. So the angle was 2/3 out of the full pi, the full 2 pi, times, we're going for area. So pi r squared, 3 squared. And then I guess we'll keep change flip again. So this is 2/3 times 1 over 2 pi times pi times 3 squared. And there's a lot of canceling here. So for sure the 2's, for sure the pi's, for sure one of the 3's. So then the area is 3. Oh, cool. That makes sense. That's believable. All right, we're getting there. We're not even on the right document though, because there's 2 more after this. But let's get this done. So we want to find the angles. Well, first off, let's find this. Is this a triple? No, this is not a triple. So we're going to use Pythagorean theorem. 4 squared plus 6 squared equals x squared. So 16 plus 36 equals x squared. 52 equals x squared. So x is root 52. And then we're going to find this angle. So let's set that up. So we've got the opposite and the adjacent. So we're going to we'll set that up as tan of theta is the opposite over the adjacent. And then we got to use inverse tangent to undo the tangent and say that theta is a tan of 6 over 4. So that's right here. And if we don't have a calculator, we can just leave it there. And then, so what does that mean for the other angle? That means that this other angle has to be 90 minus a tan of 6 over 4. That's that guy right there. All right, this is a 45, 45, 90. Because this pi over 4, that's 45 degrees. So we know that's got to be 45 degrees. And if it's a 45, 45, 90, that's 6. And that's 6 root 2. You get all the same with trig. You can get all the same with Pythagorean theorem. But if we don't need to, that's nice. So we don't have to. So then here, 70 degrees, because they got to add up to 180. And then we'll set up a sine, because we've got the opposite. So the sine of 20 degrees is 3 over x. So that means we'll multiply both sides by x. So x is the sine of 20 degrees equals 3. And then divide. So x is 3 over sine of 20 degrees. And then I think we'll do the exact same thing for tangent to get y, but we'll use tangent. So we'll say the tan of 20 degrees is 3 over y. So then multiply by y and divide by tan. And there we go. All right, so we got 3 more triangles. So let's do this one. This one we're trying to find the angles. So it looks like, let's try to find that angle first. So let's do sine, or no, cosine, because that's the adjacent side. That's the adjacent, that's the hypotenuse. That's cosine. So we're going to say that the cosine of theta is 1 over 10. So that means we're going to inverse cosine. So theta is a cosine of 1/10. We can put that in the calculator if we want to, but we don't need to. And yeah, that's our angle. That's theta. We can find the other one. That's just going to be 90 minus a cosine of 1/10. And that's just fine. All right, next one, pi over 3. So we'll do the sine. Hold on, I'm not even paying attention at all to what I'm doing. So let's see. We got x, we got y. So yeah, let's do sine. Let's do the sine of x. No. The sine of pi over 3 is x over 4. So that means x is the sine, or multiply both sides by 4. So 4 sine pi over 3. And we can put that in a calculator. I think I actually know sine pi over 3. I think it's the square root of 3 over 2. So if we wanted, we could put that as our answer. And then we'll do something similar for y, but it looks like we got to find cosine. So we'll say that the cosine of pi over 3 is y over 4. So y is 4 cosine of pi over 3, which is 4 times 1/2, which is 2. So we can leave this as the answer if we want to. But notice how this is also special triangles. 2 and 2 root 3. So it's a 30, 60, 90. So let's do the same stuff over here. Let's use cosine to find the hypotenuse. So let's say that the cosine of 70 degrees is 5 over x. So x is 5 divided by the cosine of 70 degrees. And we'll do a similar thing with tangent to find y. We'll say that the tangent of 70 degrees is y over 5. So y is 5 times the tangent of 70 degrees. All right, good. And remember, we can always put those in a calculator if we want to. We just don't need to. We can just leave it like that. That's fine. All right, this stuff is just always important. So f of 2. Remember, that's not f times 2. That's whatever's in the parentheses. That's what you're putting in for x. So this is 2 times 2 minus 3, which is 1. This is 3 times 3 squared, which is 27. This, you got to start with the inside. So you first got to say, what's g of negative 1? Well, g of negative 1, so negative 1 squared is 1. 1 times 3 is 3. So g of negative 1 is 3, which means we're really just doing f of 3, which is 2 times 3 minus 3, which is 3. And then here they don't give us a number, so we're just taking this f function, the entirety of the f function, and plugging it in for x in the g function. So we see g is 3 times x squared. So we're going to replace the x with 2x minus 3. It's going to be 3 times 2x minus 3 squared. And that's fine. We can leave that. And then here we got g of x, which was 3x squared, plus 2 times f of x. So that's 2 times 2x minus 3. Can make that a little prettier. 3x squared plus 4x minus 6. That's a little bit nicer. So we got the same thing over here. So 2 times f of 0, well, f of 0, plug in 0 for x, that's negative 1. 2 times negative 1, negative 2. F of x over g of x, well, 4x squared minus 1 over 2x plus 1. And there it is again, difference of two squares, 2x plus 1 times 2x minus 1. Cancel, cancel. That's just 2x minus 1. Okay, f of x times g of x. So that's just 4x squared minus 1 times 2x plus 1. We don't need to multiply that out or anything. And then g of 2. So g of 2, that means we're plugging in 2 into g. 2 times 2 is 4. 4 plus 1 is 5. So that means we're doing g of 5. So that's 2 times 5 is 10. 10 plus 1 is 11. F of 0 plus g of 0. Well, we already said f of 0 is negative 1. G of 0 looks like it's positive 1. So that's just 0. Okay. All right, now we got some grueling ones, honestly. So we got to graph this, and we got to complete the square. So let's bring it down here. Let's rearrange everything first. We'll just try to be really consistent. We're going to rearrange it. 9x squared minus 36x minus 4y squared plus 8y minus 4 equals 0. So we got to factor out what we got to factor out. So that leaves that. Factor out the negative 4. Y squared minus 2y minus 4 equals 0. Now we can complete the square. So we got the double parentheses. X minus 2 squared minus 4 minus 4 double parentheses y minus 1 squared minus 1 minus 4 equals 0. So now we distribute the 9. So it's 9x minus 2 squared minus 36 minus 4y minus 1 squared plus 4 minus 4 equals 0. So now we combine the numbers. Those cancel. We have 9x minus 2 squared minus 4y minus 1 squared equals 36. And we divide everything by 36. So it's x minus 2 squared over 4 minus y minus 1 squared over 9 equals 1. So then we can graph it. So this is a hyperbola. So its center is here. We got our x is 2, our y is 3. So we draw our box. We draw our diagonals. This one is x squared minus y squared. That means it's opening sideways. So it should be looking like that. So then we can write our asymptote equations. It's going to be plus or minus our y over our x times x minus 2 equals y minus 1. Excuse me. And then we can get the c value. So c is the square root of 4 plus 9, which is root 13. So that means the foci are 2 plus or minus root 13, comma 1. Root 13 is roughly 3.5. So we'll come up here and we'll go from the center about 3.5 this way and about 3.5 that way. All right, sweet. This one. So that only took 3 minutes. That's not bad. All right, so let's just do it up here. So let's go ahead and complete the square on the x. I know we said we were going to be consistent, but I guess we're not. So we're going to factor the 4 out of the y. Let's try to do this in one step here. So we're going to factor out the 4. So that's y squared plus 6y. So then when we double parenthesis, that's going to be plus 3 squared minus 9 plus 21 equals 0. Let's see if I did that properly. So then x minus 1 squared minus 1 plus 4, y plus 3 squared minus 36 plus 21 equals 0. So what is that then? That's going to be, yeah, minus 1 plus 21 is plus 20, plus 20 minus 36 is negative 16. So then we add that to the other side, and then we divide by it. So it's going to be x minus 1 squared over 16 plus y plus 3 squared over 4, because it cancels, equals 1. And this is nice, just an ellipse. So we're going to have a center at 1, negative 3. We're going to have the y radius is 2, and the x radius is 4. And then we're going to draw our ellipse. And then we got the c value to find the foci. So c is the square root of 16 minus 4, which is root 12, or 2 root 3, which is approximately 3.5-ish. So to draw them, I'm going to go out about 3.5 on each side. And the coordinates of those are, what's the center? 1 plus or minus 2 root 3, comma, negative 3. There we go. All right, 2 more. Is that the same one? It's close. But so we can complete the square on the x's. X plus 2 squared minus 4. Let's try to do the y's all in one step. So we're going to have plus 4 y minus 4 squared. And then it would be minus 16, but it's going to be 16 times 4. So it's going to be minus 64. Oh, and then plus 64 equals 0. So those cancel, so we just have the 4, and then we divide by 4. So it's x plus 2 squared over 4 plus y minus 4 squared equals 1. Oh, that's pretty nice. So then we got negative 2 and 4. We've got x radius is 2. The y radius is 1. There's our ellipse, right? It's plus. Yeah. So we get our c value. It's just root 3, the square root of 4 minus 1. So in the coordinates of the foci, man, all of these are sideways. That's kind of lame. So our foci coordinates are negative 2 plus or minus root 3, comma, 4. Okay. Oh, here's a parabola then. So we still got to complete the square. It's going to be y minus, notice that that's an 8x, but then a minus 6y. So y minus 3 squared minus 9 minus 15 plus 8x equals 0. So that's plenty nice, because we'll subtract the 8x over. We'll get y minus 3 squared, and then that's 24 combined. So that's going to be negative, we need to write it down. Otherwise I'm probably going to make a mistake. So it's going to be negative 8x plus 24. So when I factor out the 8, it's going to be y minus 3 squared is negative 8x minus 3. So 3 is the vertex. It's sideways, and it's negative, so it's to the left. Remember, this is our 4c, so we're going to go 8 equals 4c, negative 8 equals 4c. So c is negative 2. So that's our focus at 1, 3. And then we have our directrix on the other side. That's x equals 5. And then our latus rectum is 8, because that's our 4c value. So that's 4 up, 4 down. There's our parabola. Sweet. So I know that was fast, but you can slow down and look through the steps. We did the first one nice out and long, and we just kind of did the other ones as quick as possible. Oh, yeah. All right, so we got to graph the rational functions. We got 2 pages of those. That's going to be kind of grueling, but let's do it. So what all do we have to find here? Let's make our little chart first. We got to find the x-intercept. we want to find the vertical asymptotes. We want to find the degree, and we want to find the sine, and we want to find the y-intercept. Is that pretty much everything? I think so. Oh, it tells us what we should use. We should use the x-intercepts, y-intercepts, in behavior, and vertical asymptotes. Yeah. So the degree in sine is the in behavior. All right, so what are our x-intercepts? We got 2 double root, and we got 4. Those just come from the top of the fraction. Our vertical asymptotes come from the bottom. That's a 0 double root. The degree is x cubed over x squared, so the degree is just 1. The sine is it's all positive. The y-intercept, when we plug in 0 for x, they actually get undefined, so there is none, which makes sense because of the vertical asymptote. So let's see, we got a vertical asymptote here. We've got an x-intercept here and here. It's positive, so we know we start up here. And we got a cross and we got a cross, so it's going to have to be something like that. And then, oh, that's not right, because we didn't mark the double root. Shoot. What's the double root? 2. So we got a cross and we got a bounce and we got to come down. And then this is a double multiplicity asymptote. So it starts low, there's no x-intercept, so it has to go back down. And we make sure that makes sense. It's an odd degree, so we expect it to go opposite directions. So that's perfect. Okay, let's put our chart here. So we've got x-intercepts, 0 double root, and -4. We can factor this, x minus 4, x plus 2. So we have a vertical asymptote at 4 and -2. The degree, x cubed over x squared. So that's a degree of 1. It's overall positive, and oh no, it's overall negative. That's sneaky in a different color. It's overall negative. And I can't believe I didn't change that. That's horrible. I should have changed those colors. And then a y-intercept of 0. So if it's got an x-intercept of 0, it's got to have a y-intercept of 0, obviously. So that's a double root x-intercept, and then -4. We have a vertical asymptote at -2 and 4. It's negative, actually, which means we got to start down here, and we should finish up. So that's going to be there. This is a single multiplicity asymptote, so it's got to come through here. It's got to bounce because it's a double root and then go back up. It's a single multiplicity asymptote, so it's got to start down here, and then it's going to cross and finish going back up. There we go. It's all about the shape. You just got to be able to envision these shapes. These little U's and these little curves like this and these little similar curves like this. You just got to picture the shape, and you just got to go through every x-intercept and not go through an x-intercept if there's not one. So let's do the same thing. So we got an x-intercept at 3 and -4. We got a vertical asymptote at 2. The degree is x cubed over x, so it's actually 2. We expect it to be going the same direction at the end. It's positive, and we actually have a decent y-intercept here of -3 times 16 over -2. Cancel the negative. 16 over 2 is 8, so that's 24. So remember, we don't need to count 24. I can't count that high anyway. We'll just put a 24 right there. And then what else do we have? We have the x-intercept of 3 and -4. Double roots? Yeah, that's a double root. We got the vertical asymptote at 2. That's it. So it's positive. So we'll start here. We got to cross and we got to continue down. This is a single multiplicity asymptote, so then we come from up here. We got to cross that. We got a double root and finish going back up. And that makes sense because it's a even degree. So they should be going the same direction. All right. Ooh, this is a tricky one. Both of these are kind of a tricky one. I don't know if we did this so much. Let's see. So, well, first off, I mean, this is tricky. This will trip some people up. X-intercept, 2x minus 1 equals 0. That's not 1. That's 1/2. And negative 2. Vertical asymptote is 0. And it's a triple root asymptote. The degree is negative, actually, right? Because it's x squared over x cubed. So it's sort of like a degree of 0 is what we're going to say. Because this gets us 1 over x. It's negative. Wow, we got everything here. Y-intercept is none because of the vertical asymptote. So let's see, we got the vertical asymptote, and it's an odd multiplicity asymptote. So even though it's x cubed, it's going to behave pretty much just like a single root asymptote. So we got 1/2, negative 2, vertical asymptote at 0, sign negative. All right, so since it's negative, but the thing is, see, that's why this one is weird. It's in behavior. This one has like a horizontal asymptote. And it's negative. So, I mean, that means that this is going to be something like this. It's going to come out and approach this asymptote, but negatively. And then everything else is kind of similar, though. It's going to have to go up and then approach this asymptote like this. And then it's an odd multiplicity asymptote, so it's going to have to go through and come like this. And then it's going to have to cross down like that and be on top of the asymptote. And that's right? If I plug in a really big negative x, if I plug in a really big negative x, I get a positive, actually. Oh, yeah, right. And that's why I'm on top like this. Yeah, okay. That's right. I think on the test, I'm only going to give you stuff that has like a positive degree, not like a degree of 0 or a degree of negative. Oh, like all of these have a degree of 0. That's annoying. But that's okay. So x-intercept, 2, negative 2, vertical asymptote, 3, negative 3, degree, 0, sign, positive, y-intercept, negative 4/9. So y-intercept, negative 4/9, right about there. X-intercept, 2, negative 2, vertical asymptotes, 3, negative 3. So this is the same deal. It's got a degree of 0. So it's going to approach 0. It actually has a horizontal asymptote here. And then we got to be on the other side. Ah, shoot, that's not right. What's going on here? Because if we're going to cross, we're not going to be up there. Oh, it's not negative 4/9 because the negatives cancel. It's just positive 4/9. Yeah, because it's negative 4 over negative 9. So it's positive 4/9. So right there, do a little bigger. So we just cross, and then we cross, and then we go back down, and then we have to be up here and approach down like that. All right, next one's going to be a similar idea. We're going to have that same horizontal asymptote. It's going to have to approach. If we factor this, this is x plus 3 squared. So we have vertical asymptote here, and it's a double root asymptote. And then we've got an x-intercept at 0, and x-intercept at negative 4. It's positive, so we start, it's not positive. Well, it's positive, but we still start here. And then we kind of come away a little, and we cross through the intercept and go back down. And then this is a double root asymptote, so it's still down. We have to cross this and then come back and approach. Yeah. So really A, B, and C are like the best ones to practice. And the ones on your test. D, E, and F are good too, but that degree 0 and the horizontal asymptote, I don't think we talked about that during the year. But anyway, that is the end of the honors study guide. So congratulations if you got all the way through this video, because I know it is a long one.